Good day everyone, I am Harold Panahon and I'll go through the previous topic that our professor went over with us. So, ang subject natin yan ay EE333 or DC and AC machinery. So, from the word itself, machinery, pag-uusapan natin at palalawakin natin ang ating kalaman patungkol sa machines. So, let's begin with electric machine or electrical machine. Electrical machine. When energy can be converted into form of energy by using converters, these converters can be called as electrical machine. When it is used, it continuously translates the electrical input to mechanical input or vice versa. The process of these two energies is called electromechanical energy conversion. When it comes to electrical machines, so we have an input. Mechanical input goes inside the machine. Lalabas naman yun as electrical output. On the other hand, when you have electrical input goes inside the machine, lalabas naman yun as mechanical. Electric machine is a kinda like the link between electrical system and mechanical system or parameters ng electrical system to mechanical. So for electrical machines, there are different kind of it. For example, when you convert the mechanical to electrical, that is what we call generator. So sabihin natin sa bahay, kapag may generator tayo, tapos then we have fuel, tapos nilagay natin ito yung fuel to power up the generator, magkakaroon siya ng kuryente. Mostly, ginagamit ito kapag nawalan ng kuryente. Dahil ito yung backup natin to have electricity para continuously pa rin nating nagagamit yung ating mga devices na kailangan ng power. A little bit of history about generator. In 7th century, yung ginagamit nila ay yung electrostatic generator na kung saan static electricity yung napoproduce nito. At mula dito, si Michael Faraday ay nainip sa electrostatic generator kaya naman inintroduce na yung principle of electromagnetic induction. Then, doon na nag-start yung dynamos and alternators. Hanggang sa nag-evolve ito sa kung ano meron tayo ngayon. And next is the Fleming right-hand rule. Pinapakita nito yung direction ng induced current mo or generated current. Thumb represent the motion of conductor. Four fingers show the direction of magnetic field. And then, yung middle finger is induced current. Ulitin natin. Thumb represent the motion of conductor. Forefinger show the direction of magnetic field. And then, yung middle finger natin is yung induced current. So, as for electrical to mechanical, that is what we call motor. Best example para dito ay yung electric fan. So, kapag plug ka ng electric fan into an outlet and turn it on, magro-rotate yung blades niya at magpo-produce ng continuous air. Kasi nga, nag-convert siya ng electrical to mechanical output, which is yung air. For electrical machines, we have two types. It depending on electrical system that we use. So, we have DC and AC. We can call a machine an AC if the system is AC or alternating current, either in generator or motor. Likewise, the DC machines if the system is DC or direct current either in generator and motor again. So, ano nga ba ang nangyayari sa loob ng machine? Kung paano nako-convert or natatranslate ang isang input na binibigay mo sa kanya into particular output.
AC generator. The major parts of an AC generator are armature coil, field magnet, slip rings, brushes, etc. The magnet which produces magnetic flux in generator is called field magnet. The direction of flux lines is from north pole of the field magnet to south pole. An armature is a coil at which insulated conducting wire is wound over a laminated soft iron core. The slip rings are circular rings fused to the ends of the coil. They rotate about the same axis as that of the armature. Brush is an arrangement that is always in contact with slip rings. Current flows to the external circuit through this. Armature coil rotates continuously using mechanical energy. Simultaneously, armature coil deflects the magnetic flux lines and EMF is generated in the coil. This continuous motion of the armature coil helps to keep a constant current in the external circuit. DC generators. As an AC generator, the DC generator also has a field magnet and an armature coil. In DC generators, the slip rings are replaced by split rings. In DC generators also, the EMF induced by the armature coil is AC in nature. This EMF is converted into DC using split ring commutator. The current flows to the external circuit through the graphite brush is unidirectional.
So, ang basic principle niyan ay mayroong dalawang electromagnetic phenomena sa electrical machines. Kapag ang conductor ay nag-move in a magnetic field, ang voltage ay mag-i-induce sa conductor. At kapag ang current is carrying a conductor ay magpe-place in a magnetic field. Yung conductor, magkaka-experience siya ng mechanical force at magpo-produce ito ng torque. Yun ang nangyayari kasi parang nagmi-meet yung dalawang magnetic field mo at doon nagmi-meet yon in Faraday's law. Nagpo-produce siya ng force at lalabas yung needed or expected output mo. So, next, here's a basic structure ng disassemble parts ng machine upang mas ma-visualize natin ito. This is what we call the rotor and the stator. The two major component of the structure of electrical machines. Stator is the stationary part and the rotor, which is yung rotating part, ito yung ang nagpo-produce ng electromagnetic field. At kapag nangyari yon, si rotor ay iikot at magpo-produce ng output na kailangan mo. Usually, yung rotor at stator are made of ferromagnetic materials para makabuo ng electromagnetic field. Tapos, they are separated by the air gap para mag-move freely ang rotor. Kasi kung wala ito, hindi magpa-function totally. Let's go to DC machine. So, DC machine can be generator and motors. But it can be classified in two. The separately excited and self-excited. Pero bago yun, ano nga ba ang construction ng isang DC machine? So, we have the rotor and the stator. Pero dahil DC machine nga ito, in the case, ang rotor is the armature. Ito ang field poles. Ito ang nagpo-produce ng main magnetic field ng machine. For the armature, ito naman yung rotating part ng machine. So, balik tayo sa dalawang classification. Na-mention natin dito yung excitation. Ikumpara na lang natin ito sa tao. Kapag na-excite tayo, yung excitement na nararamdaman natin will generate different kind of emotions. Like masaya, kaba, or kung ano pa. Same with the two classification. Dahil ang excitation ay makapag-generate ng ibang function for self. And separately excited sa isang machine. So, pumunta tayo sa separately excited. Ano nga ba ang separately excited? Separately excited from the word itself, separately, which is magkahiwalay. Yung field winding, which is yung may coil, magpo-produce yun ng magnetic flux. Tapos, kapag na-excite ito, magpa-process na yung nag-generate ng magnetic field. Yun yung electric current. Tapos, nagse-separate yung field winding sa armature winding circuit natin. Next is yung self-excited. Yung field winding ay connected ito in own brushes and armature. Tapos yung excitation ay nangyari kapag yung armature ay nag-start ng umikot. Kaya naman yung current ay mapoproduce na. In short, sa separately excited, yung field winding ay connected separately voltage sa source. While sa self-excited, ang field winding ay connected across sa armature terminal. And mostly, mas prefer natin gamitin ng separately excited DC machine dahil marami itong advantage kaysa sa self-excited. Next, we have AC machines. We have the two classification of AC. The synchronous and asynchronous, or pwede ring tawagin nating induction machines. So kanina we have the two kinds of machines in general, which is yung generator and motor. So when it comes to synchronous generators, usually ito ang primary source of electrical energy. And as for asynchronous motors, it is usually used as motors as well as power factor compensator, or what we call synchronous condenser. At when it comes into induction motors, it is widely used as electrical motor in both domestic and industrial application. Synchronous machine. Yun yung tinutukoy na synchronous doon. Is yung speed dahil unlike sa induction machine, yung rotor nito at yung air gap ay nagro-rotate on the same speed. Kaya naman sila ay primarily usually tinatawag silang synchronous generator and alternators. And alternators means AC generators. In terms of induction machine naman, ito yung most frequently used motor sa buong mundo, which is yung appliances natin sa bahay. Reliable kasi ito at economical, meaning to say walang nasasayang na pera kapag dito ginagastos. In industrial application, ito naman yung nagde-drive sa mga malalaking machine na ginagamit. So, dito na po natatapos ang ating pagbabahagi ng kalaman. Salamat!